We're in Module 6, the novice problems, and we're looking at problem 5, and I'm going to break this one up into two parts again because it's a little long. In this particular situation, what we're going to do is we're going to build a model using the capabilities of the Analytic Solver platform, this tab here. And it really helps us build these models because it takes some of the drudgery of sampling from various distributions and then collecting data out of our hands. Although you could do that with Excel, and that's how I do it. I do it by creating my own functions and the like. So here's our problem. We have another income statement, and this time things are a little bit more complicated, but not much more than they were before. And over on the right, we have information related to the particular parameters that we're going to be using. And so let's see how we build this model. The first thing we do is we go over and we note how revenue is calculated. Revenue is equal to a value of units sold, which we don't have yet, but we will, times $25 unit price. Of course, we could make the unit price variable also. So let's begin by creating a variable here in this cell to select from this discrete distribution. This is a discrete distribution, 60% chance of 18,000, 25% chance of 22,000, and 15% chance of 24,000. The probabilities must add up to 1 here, so be sure that you've done that. So I've got a 1 here in this cell, which is really just a summation of these values. So let's create a function there that allows us to sample from this discrete distribution. If I go to Analytic Solver, and then I go to Distributions, down here there's something called Custom. This is where we find our discrete distribution. It's not in Common or Advanced or Exotic. Exotic, that sounds really interesting. And it's not in Discrete even. It's in Custom. This is where we build our own custom discrete distribution. So I go to Discrete, and it has an exemplary distribution in there. What I'm going to do is I'm going to change the values by just putting my cursor in here and grabbing these numbers, changing the values to the values that I have, which are these values. Then I'm going to do the probabilities, or the weights, which they call here, weights. And my weights are going to be these values here. I hit save. Here's my distribution, 60% chance of 18,000, a 25% chance of 22,000. These are in thousands, so you have to divide these values by 1,000. These are also in thousands, you have to multiply these by 1,000. So these are in thousandths, and these are in thousands, okay? So here's our distribution. Looks right to me. So now we have selected a value. Notice what the value is, 19,900. This is the mean of this thing. We will not select a real value until we do a simulation. So don't worry about the fact that this doesn't match any of the possible values. Cost of goods sold is equal to this value that's going to be in this cell. And the way I calculate that value is by doing the same thing as I did before, going to Analytic Solver and then going to a distribution. What kind of a distribution we have? In this case, we have a uniform distribution. Let's go to Common. Here is a continuous uniform distribution. And I go to my formula, and rather than have 1 and 0, I'm going to use the values that I have for my distribution here. Notice how the distribution is written. This time I'll write it. Psi PSI uniform from a lower bound to an upper bound. So let me just go write that into the formula. So I'm going to write equal, and this is the way you wind up doing this once you know what you're doing. Much easier than going to these particular tables. And you can see what I've got now is a value in here. Again, doesn't appear, it's a value someplace in between here. It's actually the midpoint. This is the expectation, the expected value. This is the mean, as it was before. So now gross profit is going to be equal to revenue minus cost of goods sold. Now, look what I've done with cost of goods sold. Cost of goods sold is not correct. I'm going to place my cursor here, and I have to multiply this percentage times my revenue. And my revenue is right here. Now we got it, okay? So previously I just put this value, the percentage of the cost of goods sold there. And what I needed to do is move away from that. Let me get it out of this thing. So what is my variable cost? My variable cost is also going to be a function of this uncertainty. And the possible values, the probabilities of the values are on the upper row, and the outcomes are here, 15%, 25%, and 35%. So how do I create, again, a distribution? One more time, I'll go back to the analytic solver. I go to distributions, and of course this is a custom distribution, and it is a discrete distribution. So I select my values as, here are my values. Be careful you select them correctly, because if you put the values in for the probabilities and the probabilities in for the values, you're going to have a problem. The weights are here. Hit save. What you have here is the weighted average at this point. So, or the mean of this distribution. So what is our variable cost? Our variable cost is equal to whatever is going to be in this cell times revenue. Hit return. And now I've got a new value in this cell. This is my variable cost. Here's my fixed cost. My fixed cost is simply a constant, 60,000. I enter it here. My operating expenses then are equal to the sum of these two values, nothing in between, so won't count it. Don't put anything in between there, it'll count it. So there's my value. Net operating income then is equal to gross profit minus operating expenses. My interest expense is simple, it's a constant, 8,500. My earnings before taxes equals to operating income minus interest expense. Taxes now, we have two steps. There's 0% at anything that's an EBT below 0, equal or below 0, or not positive. Anything that's positive is submitted to a 34% rate. So how do I do that? Well, remember that, excuse me, here's the taxes. I'm going to put an if statement here. If this value is less than or equal to 0, then 0, else this times 34%. So now we have our model set up. The other thing that I need to do in this particular cell, I've already done it here, I have to put in an output because this cell is equal to N19 minus N21, so we're going to subtract the earnings before taxes from our taxes and get this. I add this PSI output because what I want to do is I want to track what's happening in this particular cell. And so we're now capable of seeing a distribution, really, of what's in this cell for actually 5,000 iterations. I'll show you how we do that later. But here's the distribution. And it tells us the mean is 34,092. The standard deviation is about 34,000. Other elements that are important here, the max, the min. So we have this distribution that we can play with, and we will play with that in the second part of this video. But for now, suffice it to say, this model is active. I go to Analytical Solver. I put in 5,000 trials in here. I go to Simulate. I get my little hourglass, and what you see now is the appearance of a bunch of graphs. The graph that I'm interested in is this N23, which is our output. I identified it as output by putting that plus out PSI output in there. And again, here are the statistics. A little different this time. Why? Well, because it's a simulation, and these values are selected randomly, and they'll change, but not by much. And the larger the sample size, of course, the smaller the change that you'll observe. All right, we built the model. We're ready to start to ask some serious questions about the risk profile that we just looked at. That was a risk profile, and it gives us a span of outcomes that are likely as a result of our process. Notice I didn't have to build a data table here to get all of these simulated experiments. The model took care of that for me internally, so I didn't have to worry about creation of that data table, although it was certainly easy enough to do. All right, that concludes part 1 of problem 5 in Mod 6.